welcome dear students. We are on the CEC lectures and today's topic is the load cell. As you know, we are in the series of the electronic circuits, and in this series we discuss the next equipment which use in the construction of the electronic circuits. So today we will discuss what is the load. Basically, ongoing advancements in the load cell technology have further broadened their use. So this lecture explains the different types of load cells and exist, their basic functions, which types are best for various general uses, what are its applications, what are its features. These points we will discuss further in this lecture. So load cells are precision force measuring instrument. They offer a relatively low cost, durable and easy to install solution to almost any load measurement need. So load cells have been providing quality measurement in aerospace, agriculture, medicine, industrial weighing and many other applications for decades. We use the load cell. Load cell basically used for the measurement of the precision of the force. So what is a load cell? What is the definition of load cell? Load cell basically is a transducer or a sensor that converts the kinetic energy of a force into the quantifiable output such as an electrical signals. It means load cell is a transducer, or we can say is a sensor that converts the kinetic energy into the electrical signal. So each type of exploits some physical properties of its component materials to create this measurable output, that the strength of the output is proportional to the force applied to the load cell, and this kinetic energy of the force will be measured in terms of the electrical signal. Like the strength of the output is proportional to the force. Which type of force we use? We use the compression, we use the tension and the pressure at extra we use, and then we can get the output through this load cell. This output data can then be displayed, we can store it and or used to control complex systems. Sometimes we have to control the force, sometimes we have use further use of the force, then we can store it, we can display it, we can control complex systems. So without this energy conversion, a force would be impossible to measure. So load cells serves a very important function in converting the kinetic energy of the force into the electrical signal. So load cells are most commonly used in the industrial weighing applications such as scales, because load cells can convert forces to electrical signals. It is a very simple definition that it converts the forces into the electrical signals, and they are also often used in control systems where the force on a system affects the behavior. So load cell will convert the force to the electrical signal, and that will be used to control the systems where the forces on the system affects its behavior. So for example, we can take it as a load cell may measure the tension on the machine that winds cabling on a spool to ensure the system uses a consistent tension throughout its process. So fundamentally, load cells are in systems that test, that monitor and run industrial machinery, medical devices, aircraft loads and many other applications these load cells have, that we will discuss further. So what are the types of the load cell? How many types of the load cell? Several types of the load cell exist for the varying application. So first load cell is the strain gauge load cells. Second is the hydraulic load cells. Third is the pneumatic load cell. Fourth is the capacitive load cell, and then piezoelectric transducers. These are the various types of the load cells: strain gauge, hydraulic, pneumatic, capacitive, and the piezoelectric transducers. Now we will discuss one by one in detail. What is the strain gauge load cells? The strain gauge load cells are the most commonly used. Unlike the hydraulic and the pneumatic designs described below that converts the pressure, that strain gauge load convert the pressure differentials to measurements. The strain gauge load cell operates through the changes in the electrical resistance. So, inside each strain gauge load cell is at least having the one strain gauge devices. A strain gauge is a thin wire etched in a back and forth pattern on a non-conductive substrate materials with connectors at each end of the wire. The strain gauge functions on the elastic properties of the wire, that is, when a wire is stretched, its length increases and cross section decreases. So, the strain gauge have the elastic properties, use on the elastic properties, that a wire is stretched and its length increases and the cross section decreases, and when compressed the opposite occurs. So, in the tension case, the resistance of the wire will increase, while in the compression case the resistance of the wire will decrease. So, we measure the resistance in case of this strain gauge. So, in the tension case, the resistance of the wire will increase, while in the compression case the resistance of the wire will decrease. So, both the measurement we can do through the strain gauge cell. So, strain gauge load cells converts this change in the resistance to a load measurement. So, system using this type of the load cells direct the measured force in the way that causes a deflection or the tension or compression. It means we are measuring the tension and compression through this strain gauge. So, these devices come in a wide variety of the shape and monitor the configurations, the possible load directions, and measuring the application that use them are numerous. So, the strain gauge load components, which are: number 1, the strain gauge load cell consist of number 1, a loading platform or a system to apply the force, that is the F load. The next component, the strain gauge load cell have one or more strain gauges and excitation voltage sources and output wires to measure a change in the voltage caused by the change in the resistance of the strain gauge. So, change in the resistance we are measuring through this strain gauge. So, these are the component. You see on the screen that this is the diagram of the strain gauge load cell. Here you see on the screen that the single end beam load cell with these components and the strain gauge at the top of the beam are in the tension under the load, while those at the bottom in the compression load under the load. So, here we are having the compression as well as we are having the tension measure through this load cell, like strain gauge load cell measure the tension as well as the compression. You see on the screen that left hand side we are sending the electrical signal, and right hand side you are saying that there is a weight, that is a F load on the free end. We put the load at this end and we can measure the output through the another end, that is the electrical signal. And in between that we are having the strain gauge that measure the load, that is the F load, and then output we can get through the electrical signal, and this is the diagram for the strain gauge load cell. And what are the features and benefit and disadvantages of the strain gauge load cell? Strain gauge load cells are the most popular due to their high accuracy, low price point and general ease of use. We can easily use this type of load cell, and they have a high frequency response for dynamic load and are not sensitive to the temperature variations. Dynamic load means anytime we can put, not it is not necessary to put the static load, but the dynamic load also can be measured through this, the strain gauge load cell. And there is no effect of the temperature will not affect any output. So because they can fit into a wide variety of the load monitoring configurations, they lend themselves to almost any industrial application. And this type of the load cells are passive transducers. There are two types of the load cells, one is passive and second is the active. This type of strain gauge is the passive transducers, meaning they require an excitation voltage to operate. So this can restrict their use in the area of the limited electric supply or in area where the ignition may be an issue. So this is the strain load cell. Now next is the hydraulic load cell. This is also one of the important load cell. This hydraulic load cell converts a load to hydraulic pressure, as the name suggests, hydraulic pressure. So it converts the force into the hydraulic pressure. We put the hydraulic load, then it will give the output in form of the hydraulic pressure. The measured load is applied to a load platform attached to a piston, and this piston sits in the closed chamber filled with the fluid. And when a load is applied, the action of the piston on the diaphragm pressurizes the liquid, and the charge in the liquid pressure is directly proportional to the force applied by the load. So this liquid pressure is readable through the attached Borden tube and pressure gauge. So hydraulic load cell components are the elastic diaphragm, we are having a piston connected to a load platform, hydraulic fluid which is usually oil or sometimes water we can take to measure it, pressure gauge we use for this, a tube connecting the chamber to the pressure gauge, steel housing for the assembly. So on the screen you are having the hydraulic load cell diagram. So you see the F load is put on the piston. You see there is a load platform. You see on the upper side of the diagram, here we put the load on the load platform, and this is mentioned by the weight load and piston. When the load is put on it, then we can have the pressure gauge that will give the reading. So this is the hydraulic load cell diagram. What are the benefit of this cell? And because of the hydraulic load cell design contains the no electrical components, so this type of the load cell leads itself to environments where the explosion safety is a concern and where an outside power source may be difficult to provide. So when there is no need of the electricity or any connection, so with this type of the load cell. On the flip side, the hydraulic load cells tends to be more expensive than the other types, making them cost prohibitive for certain applications. So hydraulic cells can typically measure up to the 5 mN and have to accuracy of about 0.25 to 1% of the full scale output. So their resolution is typically about 0.02%, and because these load cells are sensitive to the ambient pressure, so the user must reset the readout to the 0 before each use. So we have to set it at the 0 before using this instrument or before using the load on that. So next type of the load cell is the pneumatic load cell. This pneumatic load cell functions similar to their hydraulic counterparts. In that they convert the fluid pressure into a load measurement. Means we are giving the load fluid pressure on the cell and it will give the output in the form of the load measurement. However, the pressurized fluid in a pneumatic cell is a type of gas, oftentimes air. So we can measure the force to be measured is applied to a loading platform on one side of the diaphragm, and the pressure supply regulator introduces a pressurized gas to a chamber on the opposite side of the diaphragm to balance out the force. So a nozzle is connected to a pressure gauge, allows some of the pressurized gas to escape the chamber. So pressure of the gas flowing through this nozzle is measured. How much pressure of the gas we can take through this nozzle, and this pressure is proportional to the force applied. Pneumatic cell components, which components have this type of cell, is the load platform to apply the force as usual, so that we can measure is steel chamber filled with the pressurized gas or air, and elastic diaphragm connected to the load platform that seals the chamber, and air supply regulator we use the nozzle, bleed valve we can say it, and pressure gauge we use in this. So you see on the screen the diagram is here. This is the type of pneumatic load cell. So you see left hand side, you see there is a air supply hole, and through here the air will be sent to the chamber. You see here, and there is another bleed valve that will be throughout the liquid. You see on the upper side there is a diaphragm, and you see there is a load platform at the upper side of the diagram. You see there is a load platform, and that is the that is used to put the weight on it. So on the left hand side, right hand side, you see no, exactly right hand side we are having a pressure gauge, so that will give the measurement, and this bleed valve is the nozzle that will be through which the gas will be supplied. So this type of the pneumatic load cell uses to measure the pressure. So what are the features of this and benefits of this pneumatic cell? So like their hydraulic counterparts, pneumatic load cells are explosion resistance and are generally used in the application with intrinsic safety concern. And this type of cell is also tolerant of the temperature changes. Moreover, this type of load cell is sensitive to a small load, so this make them practical of the systems requiring the real time accuracy with the lightest of the load, such as the dispensing fourth fluids. So this type of cell are used to measure the sensitive load also. Next next type of load cell is the capacitive load cell. Capacitive means, as the name suggests, capacitive load cell operates on the ability of the material or a system to store a charges. Like as the name suggests, capacitive, it means capacitor we will use. This consists of two parallel plates. Capacitor also having a two parallel plates, so this consists of the two parallel plates with a gap between them. You all know the definition of the capacitor is also considered two parallel plates and the gap in between that. And electric current is supplied to the plates until a stable charge forms on each one with the positive charge and the other with the negative charge, similarly as in case of the capacitor. When the load is applied to one of the plate, the gap narrows, causing a stored charge or the capacitance between the plates, and this charge creates the output of the load cell, which is then translated to the load measurement. What are the components of this load cell? A loading platform external to the housing to apply the forces, and industrial housing containing a free moving and a fixed plate. So dielectric materials we use between these two plates, it may be air, a electrical wire of the plates, a rigid rod or connectors between the loading platform and a free moving plate in the housing we require. So on the screen you are seeing that this is a one of the load resistance. This is the capacitive load resistance. You see, similarly here right hand side we put the load, that is the free end, and right and left hand side we are having the electric signal. So we can see that the weight, we put the weight on this platform and the output we can take from the electrical signal, and you see in between that there is a capacitive sensor. Here we put the load, and this capacitive sensor measure the load and the output we will can get through the electrical signal. See that you see here, this is a similar, you look, it is a similar like a capacitor. You can see that two parallel plates are there. There is a distance between these two plates. One is positive, one is negative, and dielectric in between that. That is the air. If it is air, then this one. Then refractive index will be 1. The capacitance C is measured divided C is equal to epsilon A by D, where epsilon is the permittivity of the dielectrics, A is the overlapping area of the plate, and D is the distance between these two plates. So we can measure the capacitance. What are the features and what are the advantages of this load? Capacitive cells are highly sensitive and accurate over a wide range of the forces, maybe large or maybe small. They are also rather simple in design, making them more cost effective from the other load cells, and their ability to sealed without compromising their operation makes them a good choice for the food and medical weighing applications where hygiene is an issue. So we use the capacitive cell there. Because of the capacitive load cell operates using a electric charge, they may not be good choice in the flammable environment. So we cannot use it in the flammable environment where we use the fire and all that. Also, some dielectric materials are sensitive to the temperature, which can affect the accuracy of the load resistance. Next load cell is the piezoelectric transducers. Nowadays it is using in many industries. A piezoelectric sensors operates based upon the piezoelectric effect. That piezoelectric effect means we just giving the pressure, and then output we can get in the form of the electric signal. So the piezoelectric effect is a natural property of the material such as quartz crystal and other ceramics. Piezoelectricity is produced when this polarized crystalline material is stressed or deformed. The stress then causes a shift in the operation of the internal dipoles of the material. So it is similar to the dielectricity, which occurs when a charge develops from a shift of the electrons in an insulator. So piezoelectric sensors can quantify forces, pressure and the displacement. So through this piezoelectric sensor we can measure the force, pressure and the displacement. So metallic electrodes bonded to a surface of the material form a measurable net charge, and through this net charge we can measure the force, pressure and the displacement. For proper function, the design must place these electrodes perpendicular to the applied force. So both the compression and the tension forces creates this piezoelectric effect. This compression force creates an opposite polarity of the tension forces. The output voltage is directly proportional to the applied voltage. So we can measure the compression and tension. Compression forces create an opposite polarity of the tension forces, or we can get the output which is directly output of the voltage, output voltage is directly proportional to the applied forces. What components have this piezoelectric transducers? A load platform or a system that is used to put the load, and metallic electrode bonded to the piezoelectric material. Next is piezoelectric material, output wires to measure the change in the voltage caused by the change in the charges. So you see on the screen here we are having the piezoelectric load cell diagram. Nowadays piezoelectric cells are used to develop the to convert the mechanical energy into the electrical energy. So, you see load platform is on the upper side, that is a F load. Right hand side we are having the electrical output, base is there, and left hand side piezoelectric element that is used to generate the piezoelectric effect. And you see here there is a two type of compression and tension created. You see that the polarity is totally opposite, electric piezoelectric effect within the piezoelectric elements in tension and the compression. See left hand side when on the original form, when the compression is done and when the tension is done. What are the features or what are the benefit? The piezoelectric transducer is an active transducer. So, meaning it does not require an external power sources to generate an output signal. These characteristics make the device desirable in the application where an external power sources is inconvenient. So, however, its output signal does not require amplification as it is very small. Piezoelectric effect happens for the dynamic forces. Once the force becomes static, the output of the sensor returns to the zero. So, we use the dynamic forces in case of the piezoelectric effect, in case of the piezoelectric cells. Therefore, these transducers lend themselves to the application requiring the measurement of the transient forces. Piezoelectric transducers are more durable than the other load cells and have a high frequency responses. Thank you very much.